Welcome to Notes 0.6. We are going to do Factoring Completely Day 1. So we're going to start with a review. Factor the following. So looking at letter A, I have two terms. Usually when we have two terms, we can hope that it will be dops, but this does not fit dops at all. Not only do we not have a minus sign, we have a plus sign. 8 is also not a perfect square. Y is not a perfect square. X to the third is not a perfect square, and this Y is also not a perfect square. So this is just super not dops. But we can actually pull a GCF out. So these two terms do have an 8 in common. They also have x squared, because we've got our two x terms, and we have to pick the smaller exponent, so x squared. They also both have a y in common. So I can divide both of these by 8x squared y. And I'm left with 2, my x squareds and my y cancel in the first term, plus 8 divided by 8 is 1. X to the third divided by x squared is x, and the y's cancel. So I'm left with 8x squared y times 2 plus 1x, or you could just say 2 plus x. Letter B, we want to see if there's a GCF. If we can divide everything by 3, that'd be great, because then we can do a shortcut factoring that I showed you once yesterday. But unfortunately, I know that 14 cannot be divided by 3, so we do have to do the long AC method all the way through. So my AC method, I have A times C. Again, I know I'm using the AC method because it's set up like this: ax squared plus bx plus c. So whenever we have a setup like that, we want to use the AC method. So my A value is 3. My C value is negative 49. So I'll do 3 times negative 49. And we get 147, so negative 147. If you remember the steps from yesterday from Notes 0.5, we set up our t-chart. We need to list all of the factors of negative 147. So we need to find the numbers that multiply to negative 147. And again, if you recall from yesterday, we have to pick whichever pair adds to 14. Because it always has to add to whatever your B term is. In this case, B is 14. So to get my factors of 147, I go to y equals on my calculator. Go to y equals and type in negative 147 divided by x. If that's times x. Divided by x, and go second graph. And you'll be able to see the table. Now we only want the whole numbers, so we want to skip any decimals. So I know 1 and negative 147 gives me negative 147 when I multiply. Then I know it's 3 times negative 49. That gives me negative 147 when I multiply. And let's find some more. There's 7 and negative 14. 7 and negative 21. And let's see if there's any more. These are all decimals. So the next one I get to is 21 and negative 7. So those are the same numbers, just opposite signs. So I know I've gotten all of the actual numbers. I just now can go through and switch the signs, because 49 times negative 3 is the same thing as 3 times negative 49. Same thing, 147 times negative 1 is the same thing as 1 times negative 147. So we need to figure out which of these add up to 14. 1 plus negative 147 is not 14. It's not even close. 3 plus negative 49, that's also not even close. That's negative 46. It's not even close to 14. 7 plus negative 21, so in other words, 7 minus 21, that's negative 14. I need positive 14, so since I need this to switch, these also both need to switch, which is what I have right here. The 21 switches to a positive. The 7 switches to a negative, so therefore my answer is going to switch also. So that is my positive 14. So I'm going to circle my pair, 21 and negative 7. That is the pair that I use to split the middle. So I bring down my first and my last term, 3v squared minus 49, bring those down. And I need to split up the middle term. So instead of 14v, I need 21v minus 7v, because those are the numbers I got from my t-chart. Now I have 4 terms, which means I can factor by grouping. So I've got group 1 and I've got group 2. The GCF of group 1, I can divide these both by 3. And they both have a v in common. So I'll divide these by 3v, leaving me with v plus 7. And now my GCF of the second group is going to be a negative number, since I have that negative in between the groups. And the biggest number that goes into 7 and 49 is 7. So this is a negative 7. Again, this GCF does not have a variable because this does not have a variable. When I divide negative 7v by negative 7, I get positive v. And negative 49 divided by negative 7 is positive 7. Since these match, I know I've done it correctly. So I have v plus 7. And then I take my GCFs, the 3v minus 7, and that is my other factor. So my answer, v plus 7 times 3v minus 7. So factoring completely, whenever it tells you to factor completely, it says this word completely, it usually means we'll have to use multiple methods of factoring in the same problem. So the very first thing you're going to want to do is always look for a GCF. Step 1, no matter what, look for a GCF first, and that means numbers and variables. See if those terms already have something that you can pull out right away. Just like we had the GCF in letter A. We pulled a GCF out to begin. Step 2A. If there are 4 terms, try factoring by grouping. It'd be best case scenario if the problem starts with 4 terms already, because then we don't have to do any of these steps that we had to do up here. We don't have to worry about splitting the middle if the middle is already split. If there are 2 terms, see if it's DOPS, because if it's DOPS, then you can do that pretty quickly. If there are 3 terms, we have to use the AC method, which is what we just did in example B. So looking at number 1, I see I've got 3 terms here, but I'm not going to get there yet. I want to go to step 1, and that's always look for a GCF first. So if I look at number 1, I actually have a GCF. I can divide all of these terms by 3. So I pull a 3 out, and I'm left with x squared minus 7x plus 12. This is now what I'm focusing on. That 3 is just going to live out front. We're going to ignore that 3 for the rest of the problem until I write my answer. So I'm focused on the x squared minus 7x plus 12 now. This is 1, 2, 3 terms. So according to step 2, I have 3 terms, so I'm going to follow step 2C. If there are 3 terms, use the AC method. I have to use the AC method, but there's good news. We can do the shortcut AC method. And the reason we can do the shortcut is because now this x squared does not have a number in front of it, meaning it has an imaginary 1. And we can do the shortcut whenever there's an imaginary 1 or a 1 attached to the x squared. The shortcut saves us time because I can set up my parentheses right away, and I can put whatever variables in the question. So x squared is given to me by x times x, so I can put the x's here. And to figure out what else goes in the parentheses, I just have to do the t-chart, which is the AC method. So I'm doing A times C. So A times C, that's 1 times 12, which gives me 12. That goes on the left side of our t-chart because we need to list the numbers that multiply to 12. And on the right side, I'm going to write down plus negative 7. That means I'm trying to find the numbers that add to negative 7. And that's always whatever B is. You want them to add up to whatever the middle term is, whatever B is. So I'm going to list my factors of 12. I know 1 times 12, 2 times 6, 3 times 4. And now I'm going to add them up and see if any of them give me 7. So 1 plus 12, that would give me 13, so that's not it. 2 plus 6 gives me 8, so that's not it. 3 plus 4 gives me 7. That's close. I just need it to be -7. So if I want to flip this, I also need to flip these. So the +3 becomes a -3, the +4 becomes a -4, and the +7 becomes a -7. So those are the terms that I am going to use. Now, if this was not a shortcut problem, I would have to split the middle and do this whole process that I just did up here. But because it is a shortcut, once you get the numbers from the T-chart, those are the numbers that go directly into your parentheses. So one of them is a -3 and the other is a -4. And then you take your GCF from the beginning of the problem, this 3 that we pulled out initially, that has to get put into your answer as well. Like I said before, we're going to forget about that until we write our answer down, and since we just wrote our answer down, we have to bring that 3 back and put it in front. And that is our answer. So that actually was 2 different types of factoring, because the first thing we did was find a GCF, and then we did the AC method. Number 2 is going to be similar. I see there's definitely a GCF between these 3 terms. They can all be divided by 5, and they all also have a variable. They all have b squared. Well, at least b squared. So we are going to use the smaller exponent, which is the 2. So I can pull a 5b squared out of all 3 of those terms. When I divide 5b to the 4th by 5b squared, the 5's give me a 1, and the 4th power divided by the 2nd power, when I subtract them, I'm left with 4 minus 2, that's 2. So I have 1x squared, or sorry, the letter is b, 1b squared, minus 20 divided by 5 is 4, and b cubed divided by b squared is just b, minus 105 divided by 5, I think that's, it's 21. Okay, so that's 21, and the b squareds cancel. So that was step 1, finding the GCF. But now if I look what I have left over, I've got 3 terms. So it's just like the last question. I pulled the GCF out, and then I focus on what's left. I've got 3 terms, which again, if you follow your steps, if there are 3 terms, use the AC method. So I've got A, B, and C. We have great news again, though. A is 1, which means we can do the shortcut. Whenever I can do the shortcut, I can set up my parentheses. In order to get this b squared, that would be b times b. I'm going to bring that GCF down now so I don't forget it. To figure out what goes in the blanks, the rest of those parentheses, that's where I do the AC method. So A times C equals, well, the A is 1 and the C is -21. So 1 times -21 equals -21. So if I go to my T-chart, I need the numbers that multiply to -21. It's whatever you get when you do A times C. And I need to figure out which of them add to -4. That -4 is coming from B. It's always got to be, it has to add up to whatever that middle term is. So I'll list my factors of 21. I know it's 1 times -21. 2 doesn't go into 21. It would be 3 and -7. And that's really it. You can reverse around the numbers as well. You could say it's +7 and -3 and +21 and -1. But I already see my answer right here. It's 3 and -7. If I add 3 plus -7, I get -4. So those are the terms that I'm going to circle, and that's what's going into the parentheses. I can skip all the other stuff because this is a shortcut. This is the shortcut because I had the 1 in front of the b squared. So I can just put that +3 and that -7 in the parentheses, and I'm done. Here's my answer. All right, number 3. Step 1 is always see if there's a GCF. I know that these both have a y in common, so I can divide these both by a y. They also can both be divided by 6. So my GCF is 6y. And when I divide by 6y, I am left with, these gone, I'm left with x squared minus 54 divided by 6 is 9, and the y's are gone. So that's step 1, factor out the GCF. But then you have to look at what you have left. I've got x squared minus 9 left. That's 2 terms, and if you have 2 terms, according to the steps, if there are 2 terms, see if it's dots. Well, in order to have dots, we need a minus sign, and we need perfect squares. I have a minus sign, and I have perfect squares, which means this is dots, so I can break this down on the side if you recall dots from notes 0.2. My x squared, my minus sign, my 9. X times x is x squared. 3 times 3 is 9. So if I put these together, I have x plus 3, x minus 3. Same pattern for dots every time. X plus 3, x minus 3. And I just have to remember to bring that GCF from the beginning down to my answer. And there we have it. 6y times x plus 3, x minus 3. So step 1, I had this GCF at the beginning. And then step 2, I had dots. And that's how I ended up with this whole answer. Number 4, I see numbers that can all be divided by 5, so I'm going to pull the 5 out. They also all have a variable, so I'm going to take an x out as well because the smallest of them is just this x. So my GCF has to be a normal x. When I divide 5x to the third by 5x, I'm left with 1x squared, or just x squared. When I have negative 55 divided by 5, I have negative 11. And x squared divided by x is just x. Plus 150 divided by 5 is 30, and my x's cancel. So that was step 1, pull out the GCF. Now step 2 is look at what you have left. I've got 1, 2, 3 terms. 3 terms is the AC method. So A times C equals, this is an imaginary 1, which is great news for us because that means we can do the shortcut. So it's 1 times C is 30, 1 times 30 equals 30. So I need the numbers that multiply to 30, and they have to add up to whatever B is. In this case, B is negative 11. There's B. So the factors of 30. I know 1 times 30, 2 times 15, 3 times 10, 5 times 6. 1 and 30 add to 31. 2 and 15 add to 17. 3 and 10 add to 13. 5 and 6 add to 11, but I need negative 11. So if this is backwards, I need this to switch. That means I need to switch both of these. So in order to get a negative 11, I need a negative 6 and a negative 5. It still works because negative times a negative still equals positive 30. So I'm going to circle these, and because this was a shortcut, because I had a 1, I know that I need just 2 sets of parentheses, whatever letter is in each of them. I'm going to put that GCF out front, and then take the numbers from your T-chart and put them in the parentheses. And there you have it, your answer. Okay, number 5. Looking at these, I can see they both have b squared in common. And if we want to see if 27 and 121 have any factors in common, see what their GCF is, I can go to my calculator, go to the home screen, remember math num 9, so math over to num option 9, and type your 2 numbers in, 27, 121, enter. Our answer is 1, so that means they don't have anything in common other than the number 1, which everything's divisible by 1, so that really means nothing. So the only thing I can pull out of here is b squared. Oh, and they also share an x. Didn't see that at first. we've got an x in this one, x to the third in this one. So I can only pull out one x because that's my smaller exponent. So I pull out b squared x. When I divide, I'm left with 27. The b squareds cancel. And then x to the third divided by x to the first is x squared. Plus 121 stays. My b squareds cancel and my x's cancel. Once you pull your GCF out, you look at what you have left over. I have one term, two terms. Two terms means you need to look to see if it is DOPS. Since 27 is not a perfect square, and also there's a plus sign inside of a minus sign, instead of a minus sign, this is not DOPS. That means you are done. I can't do the AC method because there's not 4 terms, or 3 terms, and I can't do grouping because I don't have enough terms. So this is it. This is your answer. For number 6, I can divide these all by 4p cubed. When I divide, I'm left with p squared plus 11p plus 30. This is great news because when I look at what's left, I have 3 terms, but my p squared doesn't have a coefficient, which means it's an imaginary 1, which means it's a shortcut. So I can set up my answers now, put a p in both of them, bring down the 4p cubed. I just need to get the numbers that go here from my t-chart. So I have to do the a times c. So a is 1, c is 30. So a times c equals 1 times 30, which is 30. So I need to find the numbers that multiply to 30, and they have to add to 11 because that's my b term. Always has to add up to the b term. So I have to add to 11. I just listed the numbers that multiply to 30 back in number 4. It's 1 and 30. Oops, 1 times 30, 2 times 15, 3 times 10, and 5 times 6. We know 5 plus 6 equals 11, so that's what I'm going to circle, which means I have a positive 5 and a positive 6 going in my parentheses, giving me the answer of 4p to the third times p plus 5 times p plus 6. Okay, number 7. Those are both even numbers, so I can definitely divide these both by 2. They also both have a y in common. I have y and y to the third. This is my smaller one, so that's what goes into the GCF. So I can divide these both by 2y. 72 divided by 2 is 36. My y's cancel, leaving just x squared. And bring down the minus. 2 divided by 2 is 1, so those just kind of cancel because I have y cubed divided by y, which leaves me with y squared. Looking at what I have left over, I have 2 terms. First term, second term. Whenever you have 2 terms, according to your steps, you need to see if it is DOPS. Well, I'm in luck because 36 is a perfect square. X squared is a perfect square. I have a minus sign, and y squared is a perfect square. So since these are all perfect squares, this is DOPS. I can break it down. 36 is 6 times 6. X squared is x times x. Then I hit my minus sign, so that's where I separate the top from the bottom. Y squared is y times y. So I group these up. 6x plus y, 6x minus y. That's what this turns into. But I have to remember that GCF from the very beginning. It has to get stuck in front of your final answer. And that is it. 2y times 6x plus y, 6x minus y. Last question. See what 218 have in common. So we can do math num 9. I mean, I know they definitely can both be divided by 2, but let's see if there's something bigger. So math num 9, 200, 18. enter, oh, no, 2 is the biggest they can be divided by. So these can both be divided by 2. They also both have an x, and they both have a y. So I have to use this x and this y in the GCF because those are the smaller ones. So I pull out 2xy, and I'm left with 100 x squared, y's cancel, minus 9 x's cancel, and then that's y squared. So GCF came out. Now look what you have left. I've got 1 term, 2 terms. Anytime you got 2 terms, you got to see if it stops. Well, I do have a perfect square here. This is also a perfect square. 9 is also a perfect square. Y squared is always also a perfect square. And then I have a minus sign, which is perfect. That means this is DOPS. So I have 100, I have x squared, I have the minus sign, I have 9, and I have y squared. 100 is 10 times 10. X squared is x times x. 9 is 3 times 3. And y squared is y times y. So I can group these up, put a plus on the line, put a minus on the line. So I have 10x plus 3y and 10x minus 3y. And then the 2xy goes in front. All right, that was notes 0.6. You can now work on homework 0.6, and then we have one more lesson left in this unit, and it is on the same topic, so hopefully we'll be able to have an easy time with the rest of this.